Good afternoon, good evening. Shida, how many times have you seen me giving a lecture?
More than 100 times.
Good. And how many times I was late?
Not even once.
Okay. Just a reminder for everyone. It is 9:31.
Yeah.
Where are my students? All right. Good morning, Chinmay. Good morning, Vishal. Oh, good evening.
Yeah.
Annie is here. All right. So very exciting today. So I was looking forward to this lecture. It's one of my favorite ones. So today we're going to continue on the trees. Deja vu, yes. If they say if you repeat it 100 times, it's going to stick eventually, right? So for people, they came a little bit late and they're coming late. Someone should repeat the conversation on the chat for me. Can you type it in, Mohan? Professor said that. All right. So you see my slides, right? All right. Today we're going to talk about stopping conditions, right? Last time we built the tree, and now we're going to figure out when do we stop growing the trees, right? Okay. So before we go there, I wanted to go a little bit a history of your life with us. This is kind of you on the ed exercises, right? We have the training wheel, we put you in the track so you know where to go, right? Then you went to labs, right? And Arya and the TFs are holding you, just let you a little bit to go, right? And then we give you the homeworks, right? All by yourself, right? And then if you stick around all the way to AI5, what's going to happen? You're going to become a real professor with a motorbike, okay? That's me, but all right, let's go. Stopping conditions for you. So we motivate. We said that trees are good when we have complex decision boundaries and we wanted something simple, right? Something we can understand. If I give you a decision tree, it's very easy to understand. If that's bigger than that, your chance of getting diabetes is harder. If your blood pressure is higher, your chances of getting heart disease will be on the yes side, right? And if you're obese, another one, etc. Right? So the explanation of a decision tree is doable, especially, and that's a special thing, if every predictor appears only once, right? If they appear more than once, it gets a little more complicated to explain. And then we talk about splitting criteria, is how we grow the tree. And in some strange way, we're not having like our loss function and we minimize it. We minimize it in a greedy way. So every step of the way, we're trying to minimize the entropy or the increase the purity, right? So it is minimizing the purity, but you do it in a greedy way. So for logistic regression, linear regression, what we did, we put the loss function and we minimize it, boom, right? Now we grow it up. So as we go on, we're minimizing, and we hope that greediness will give us the best. At one point later in your career, on your journey in data science, we're going to go the other way around. We're going to go to the loss function, and we're going to grow it by going backwards. That's called backpropagation, right? So there's three kind of ways of doing that. All right, today we're going to talk about stopping condition, and we start. A question for you. Raise your hand, and remember, videos are mandatory to be on. I already kicked out 3 people, so watch out. Don't go to the bathroom. You go to the bathroom, let the video on. So if we don't terminate the decision tree algorithm manually, what would the leaf nodes of the decision tree look like? I'll let you raise your hand or jump in for now before I start making calls. Let's say we don't stop and we keep splitting. What will happen out there? Mohan.
Like each leaf node will be each data point, sir.
Yeah, precisely. So if we're here, we split, and we split again. And if we split again, each leaf node will have one data point, right? Well, that's not a very useful decision tree. Why?
It is not generalizing, sir. It is overfitting.
Yeah, exactly. 1 year in a row. So the tree will continue to grow until each region contains exactly one training point, and the model will have 100% training accuracy, but it will suck when we look at it in the test set or validation set, right? Good. That's clear, no? All right. Now, the question is, how can we prevent this from happening? What can we do? Well, let's ask a student.
Stop it somewhere.
Sumant, you said stop it from growing, right?
Yeah.
All right, let's get some ideas here. How would you stop it? You say stop, like there is this game that you play with the kids and you say freeze and they have to stop running. Is that what you mean? We're just running at one, we say freeze and whatever you have. Actually, I've never seen this before, but could be work, randomly stop it.
Since splits are based on our gene index, so we can say that if gene index is not increasing or something by that for a certain number, then we'll stop it.
Okay, that's a great idea. And it's actually my last bullet. So Sumant says, just keep calculating the change in the purity after every split. And if it doesn't increase, decrease, stop, right? Up to a threshold, I assume, Sumant, right? Yeah. Ashish Kumar,
Yes, Professor.
any ideas how to stop it from overgrowing? You have a tree and it's overgrowing. What are you going to do?
So we can check for bias variance trade-off. Like if the motive to prevent it from overfitting is like to prevent the leaves to split up is to stop overfitting, right?
Okay, so you say you can monitor the validation.
Yeah.
Is that what you mean? Validation accuracy or purity? What would you monitor?
Should be k-fold cross validation accuracy.
But what is you validate on what metric? Be precise, guys. Answer the question precisely. You have a cross validation. What's the metric you measure?
Mean squared error accuracy.
Mean square accuracy?
Means accuracy is a metric.
Accuracy is a metric for classification. Thank you. Good. Okay, that will work too. Thank you, Ashish. Any other ideas?
We could specify tree depth,
What?
like the depth of the tree, like
Depth.
how many layers of nodes.
All right, so we have depth. I think Ashish's idea is on the depth too. He just goes down, checks the validation set, keeps going until it turns around, right? I think that's what he meant. Right?
No, I mean, I meant we could specify a maximum depth.
Maximum depth. Okay, so let's start with the maximum depth. Here it is. Mr. Chime Amukar, he said we do maximum depth. So this is depth 1, depth 2, depth 3, right? And then we can just decide on the depth by doing Ashish method. We just check for each depth what is the validation accuracy, right? Okay. So Ashish, why don't you use the purity of the validation set?
Pardon, Professor, I didn't get you.
You said to the metric you're going to use, you said MSE accuracy, but I assume it's accuracy, right? Why don't you monitor the purity, the gene index? Anybody knows it to answer this question? Ashish said, monitor the validation accuracy, and when it starts going up, or we find the minimum, right? That's actually what you're saying, right?
Yes.
So the question is, in case you missed it, is why not the validation purity? Will the validation purity work?
So it should work, right? Because the accuracy and the purity will go hand in hand, right?
Yeah, it will work, but hand in hand, but not exactly a partner, but very close. And I prefer the Ashish method, the accuracy. Why is that? Okay, let's say you're in an interview. I'm your interview, about to get a job, and I ask you, okay, let's get a person. Chime,
Yes.
why would you prefer the accuracy and not the purity? And what's the difference? This is the question you'll be getting.
Probably accuracy would be easier to measure for multi-class.
Why is it easier? Not easier. People have count, you count. Tell me your thinking. I want to hear your thinking. Not to give me the answer. I want to hear you think. How do you go about that? Come on, let's get this ball rolling.
So when you look at the purity, it's just the weighted average and weighted average of the thing. And then
Okay.
for accuracy to be better.
Anybody else want to tell me how he thinks about this? Aparna, can you go, please?
Accuracy, because it is something closer to the model, which we can, say this is the final model, but purity will not be really the model as such.
Okay, I like that. So Zuman said, look, accuracy is what I care at the end. I don't care about purity. If I go and tell my boss, hey, my purity, my gene index is that, doesn't care. I want the accuracy. That's the thing we care, right? So I get it. I agree with you. So they go hand in hand. I think Aparna is right, but not exactly Aparna. There's not actually a monotone function as far as I know. But they're, in general, when the purity decreases, the accuracy will go up, if assuming balanced data set. But at the end of the day, what I care is accuracy. Right? So accuracy is what I care about my model, my final model. Why not measure that? Okay. All right. So when I ask questions from now on, you have to answer, and you have to not just give me the answer. Tell me how you're thinking. Like Sumant just gave me his thinking. I get it, right? Even if it's not 100% the question I wanted, the answer I wanted, I got it. So get to this habit to explain your thinking, right? All right. What else can we do? We don't split the region if all the instances in the region belong to the same class. Obvious, right? So if I go like that and I'm there and every leaf has the same class, there's no point of splitting that, right? It's a wasteful split, right? Because they're all gonna do the same.